Okay, so this is just a video to summarize what we did last lesson because I think we ran out of time. So we're looking at stopping distance, and just to be clear then, the stopping distance is the total distance it would take for a car to come to a stop, or anything really to come to a stop, once the person who is controlling the car or whatever it is, they see a hazard and then they finally come to a stop. So the stopping distance is the distance between the point at which they see the hazard and then coming to a stop. So breaking that distance down, you realise that the car's going to travel a certain distance while the driver actually reacts and presses down on the brake pedal. So this distance that the car would travel then would be known as the thinking distance, and then the rest of the distance would be the braking distance. So the thinking distance is dependent entirely on it's dependent on two things. It's dependent on the driver's reactions and on the speed of the car. And then the braking distance is dependent on a few different things. That's also dependent on the speed of the car, and it's dependent on things relating to friction. So apart from speed affects both of them, but apart from speed, the only things that affect thinking distance is going to be everything to do with the driver, like their reaction time. So you've got to think about what kinds of things will affect their reaction time. And braking distance is all to do with friction, so it's what kinds of things would affect the friction. And as I said, speed would affect both. So that one was fairly easy, and they often stopped teaching it at that point. What we did is we taught it at quite a high level. So we looked at what a speed time graph would look like for that situation. So first of all, the driver has seen it but hasn't reacted, so the car continues to travel at a constant speed until the driver reacts and puts the brake down. And then we would say we're going to assume that the car decelerates at a constant rate, so we've got a straight line going down to the point at which it stops. So we started to then label some of this graph with a few different things that we can talk about. So the time, this period of time here, would be the reaction time. I gave the symbol TR. U is the initial speed the car was traveling at, and then it's how do we combine this, work out this bit here. So what we also talked about, and we went into a little bit more detail explaining why, but the area under a speed time graph is the distance. So as I said, there's a really good simulation in my resource bank that explains that in a little bit, it enables you to play around with that, but I won't go into that for this video. So the area underneath this speed time graph would represent the distance. So I can start off by chopping it up into two shapes: a rectangle, which would be just length times width, or height times width. The height would be u, the distance, the vertical height is u, the vertical length, multiplied by the reaction time tr. So I've drawn it again down here, and as you can, so we've got u times tr over there. Next thing is to work out, well, what's TB then, which we can call the period of time which he brakes. Well, that's going to be dependent on a few different things. It's going to be dependent on the friction caused by the car. So what we did then, let's have a think about this for a moment. Okay, so we started off by saying the acceleration would be equal to v minus u over t, and v would be 0 because it's going to come to a stop. And so the acceleration would be equal to minus u over t. Rearranging that, we can see the time would be equal to minus u over a. I won't go into how I rearrange that. I'm reasonably confident you'd be able to do that. And then we came up with this bit here. So how did I come up with this? Well, we know that force, I did it up here, look. Force is equal to ma, so A is equal to F over M. Now F would be the frictional force causing the car to decelerate. So what we can do now is we can sub the F over M into where A was. When you divide something by A, it's the same as timesing it by 1 over A, which means I can flip this upside down. So maybe I can just add in a couple of steps here just to make it really clear. So this is the same as saying minus U multiplied by 1 over A, and that is the same as saying minus U multiplied by the upside down of this, which is what 1 over A would be, M over F, and that's where we are with that one so far. So next is to let me just have another look at this. Okay, so the next thing we did is we looked at this triangle here, and let's get a thinner pen. And so remember, the total area is going to be equal to the first area plus the second area. This second area, the area of the triangle, because it's a triangle, it's going to be half base times height, and the base is TB, and the height is U. Now the time TB, is this one here. That'd be TB. So let's sub all that in. In fact, I think that's what we've done here. So TB is, I've put it just up there, but I got rid of the minus sign because we're just looking. We're not so interested in. I mean, the reason why we would get a minus sign is because it's slowing down. So we can kind of ignore the minus sign because we're just looking at the size of it as opposed to what direction it's going. We just want to know the total distance, not. The fact is, it was an opposing force, and so this would be a negative as well. So anyway, so we're just looking. We're going to ignore the sign, the negative symbol. So when you put in this value here without the negative symbol into this, you would get what we've got up there, which comes up, which can be simplified to this one here. So that would be what the braking distance is. Okay, so I've just, the U squared comes from this U multiplied by that U there, and all of this, if I just highlight it, I don't want to go into too much unnecessary detail, but I also want to make it clear. So that is that, which is also that. If I can highlight this whole bottom bit in the same color. And of course, that's what the braking distance is, BD, and this is the thinking distance, TD. And so, of course, the stopping distance is going to be equal to that plus that, which is what we've got up here. So that was a pretty advanced stuff that we did. Again, you won't need to do that at GCSE, but it's quite nice to just think these things out with a bit more detail sometimes. So yeah, that's what we did last lesson.